Welcome to the first weekly math challenge of the year 2019. I want to take this time to express my gratitude for all of the support I have gotten over the past year. 2018 really has been an amazing year for our channel. And I say our because you, the viewers, you are the ones who discuss the problems, watch the videos, who graciously point out my mistakes, who participate in these weekly math challenges, and who bring, above all, who bring the unique personalities to make this community truly great. I'm really blessed to have viewers like you, and again, I cannot thank you enough. Now let's get to the 74th weekly math challenge, and before I show you the question, I want to mention a few points. There's going to be one question posted every Wednesday, US time. I encourage you to comment your answer below along with an explanation, keeping in mind that only unedited, non-reply comments will be accepted. Up to the first 10 people to correctly answer the question will be recognized as shown. Congratulations, Reynolds45, for being the very first person to post a correct explanation to the last week's challenge. Let's recognize 6 more people for this week. Congratulations, Zain Majumder, FemPianist3, Nicola C. Congratulations, Rishav Gupta, Quickinator117, and last but not least, adandap. Congratulations to every single one. Now let's get to this week's challenge. Let n be an integer greater than or equal to 2014. If the summation from I equals to 2014 to n of sine of ix minus tangent of 3x times cosine of ix is equal to tangent of 3x plus the summation from I equals to 1 to 2013 of 2 times tangent of 3x times cosine of ix for all real x such that both sides of the equation are defined. Find all possible values of n.